Good day everyone, this video is about service learning for separation process SETK3323. The objective of this video is to expose and educate students of secondary school and society about chemical engineering. What is chemical engineering? Chemical engineering creatively combines chemistry, physics, biology, along with mathematics to address the world's need by creating new technology and improving existing technology. The job scopes of a chemical engineer is to deal with chemical production such as fuel, drugs, food, and many other products. This includes designing equipment, systems, and processes for refining raw materials to make valuable products. Besides, they need to transform processes developed in the lab into practical applications and employed by large-scale manufacturing plants to maximize productivity and product quality while minimizing costs. Many people wonder about the differences of chemist and chemical engineer. Actually, chemists focus on reaction in smaller scale and chemical engineers need to scale it into larger scale. Furthermore, chemists understand deeper level of chemical reaction during the process, but chemical engineers need to understand the chemical process going on in the reactor. Last but not least, chemist is majored in chemistry, while chemical engineer is not directly chemistry related. Which fields chemical engineer work in? They can work in pharmaceutical industry. In mass production of medicine, chemical engineers are able to optimize pharmaceutical processes so that they are safe, accurate, and effective. Besides, they can work in food production. They invent techniques that enhance the quality and increase the shelf life of the food and come up with the technologies that can protect us against foodborne disease. Furthermore, they can work in environmental field as well. They develop advanced technologies, monitoring devices, modeling techniques, and operating strategies that reduce the volume and toxicity of pollutants allowed to enter the air, waterways, and soil.
There are various types of mixture exist in this world: a solid liquid suspension, a mixture of miscible liquids, and solution of miscible liquid which are difficult to separate. Thus, distillation process is used. It is a process to separate solution based on different boiling points. The idea of distillation is heating the liquid to force one component which have lower boiling points in the gas phase that we can collect the vapor and condense it elsewhere. There are several types of distillation, include simple distillation, fractional distillation, steam distillation, and many more. In simple distillation, mixture of two miscible liquid is placed in the round bottom flask. Let's take an example of acetone and water. The round bottom flask is sealed at the top to avoid vapor from escaping, and the thermometer is inserted to measure the temperature inside. Since acetone has a lower boiling point, it will be distillated. The mixture is heated until it reaches the acetone boiling point. Then, the acetone starts to vaporize. The gas rises and passes through the Liebig condenser. The condenser has cold water running through the jacket to keep the temperature cold. The vapors condense and it flows through the Liebig condenser. The condensed acetone are called distillate. It's collected in the beaker. When all the acetone vaporizes, water is left in the flask. Thus, separation process is done. What will happen if you use different mixture of liquid with similar boiling point, such as methanol, ethanol, and propanol? When this liquid is heated, more than one of them will evaporate, and so they won't be separated into pure substances. This is where we use the fractional distillation. The vapor of the mixture will now pass through a fractional column before it flows to the Liebig condenser. The fractional column usually contains lots of little glass rods, which increase the surface area, and the top part of the column is cooler than the bottom. When the solution is heated, methanol will vaporize first, and it has the lowest boiling point among the liquid. It will then pass through the condenser and be distillated. However, sometimes ethanol and propanol would be also evaporated, but as it rises to the fractioning column and come in contact with the glass rod, which is much cooler than the boiling point, they condense back into liquid and fall back to the flask. Thus, the distillate will be only pure methanol. The difference between two types of distillation is, in simple distillation, it can separate miscible liquid with at least 50 degrees Celsius gap, while in fractional distillation, similar boiling point can be separated.
Now, we will look at the application of distillation. Distillation has many applications, and these applications are used in most areas of bioengineering. Firstly, we will discuss on the application of distillation in scientific use. In pharmaceutical research, distillation can be operated in batch or continuous mode in single or multiple steps and can be run for a variety of objectives. Fractional distillation is used in pharmacy for a variety of purposes, including the separation of alkenes, the production of pharma-grade alcoholic solutions, and even the breakdown of cannabis for its oil. Next, distilled water can be obtained by distillation. Distillation is one of the methods to purify ocean water and works well since salt, microorganisms, and other components of seawater are non-volatile. Seawater desalination is sometimes used to provide the country with drinkable water. Desalination of seawater is a process which removes excess salt and minerals from water, or process of changing seawater into potable water. There are 4 types of seawater desalination, which are multi-stage flash, vapor compression, multiple effect, and membrane distillation. Water purification is a process that aims to clean the dirty water that includes soft and dissolved materials, and distillation helps us to do the process. Scientists discovered an ideal water purification system that removes both sides of the unwanted substance from the water. The water that cleans can be used for the applications of supplying drinking water, food processing, construction, industrial processes, swimming pool, and other water-based utilities.
Next application is the crude oil refining. Crude oil contains a variety of hydrocarbons that have different boiling points. Firstly, to separate these compounds, the oil is sent to a boiler to be heated into a super hot mixture of liquid and vapor. Then the mixture is fed into a distillation tower where the compounds with a lower boiling point rise up as vapors and the compounds with a higher boiling point fall downwards as liquid. The distilled products are piped off, which include petrol, diesel, asphalt, and many more. Petrol is a fuel in liquid state in the fuel tank and fuel injectors. It is a mixture of organic compounds containing carbon and hydrogen. Diesel is any fuel that can be used in diesel engine for transportation. It has a higher density than gasoline and is simpler to refine from crude oil. Alpha is commonly used to make roots. It is a colloid of alphateins and malteins that is separated from other components of crude oil by fractional distillation. Besides, alcoholic beverages is also one of the applications where the process of distilling alcohol starts with the fermentation to produce alcohol. Fermentation is an organic process that converts sugars into alcohol by using metabolic process of yeast consuming glucose to create the waste products ethanol and carbon dioxide. Alcoholic vapors rise in the neck of the wash tube due to its lower boiling point than water, while the water is left in the wash tube. In the shell and tube heat exchanger, alcohol vapors are cooled and condensed. The distillation process is repeated in spirit still. Incorrectly distilled spirit may contain fermentation byproducts and may cause very serious health problems if consumed excessively. The use of natural ingredients such as herbs and water in a beverage should not suggest the formation of a hazardous waste during the production process because it contains heavy metals and requires treatment before disposal. That's all about distillation. Thank you. Please like and comment our video.